the sum of a geometric series formula. Let's begin with this sequence or series that we started with at the beginning of class today. And to see where this formula comes from, I want to ask you if you think this is true. This 1 is just 1. This 5 is 1 times 5. True or false? True. Plus 25 is 1 times 5 twice, right? This is how this series or sequence is growing. This next term is the first term 1 times 5 how many times? 3. And then this last one, 625, is the first term times 5 how many times? 4. Notice how that time I used an exponent because I didn't want to write 5 times 5 times 5 times 5. Could I do that every time? Could I make this 1 times 5 squared and 1 times 5 cubed and 1 times 5 to the 4th? Yes? Say yes. Yeah, right? That's really what it is. This is 1 plus 5 plus 25 plus 125. In math, we can make numbers look different, right, with different symbols, like 5 cubed instead of 125. Okay? I'm setting you up for how this formula works or where this formula comes from. And the next thing I want to ask you is this. How many terms are here? 5. And the last term in the list has what as its exponent? 4. Would that be the number of terms minus 1? Okay, that's an important point for the derivation that we're about to do. We know from our previous work that all of this adds up to 781. And that is known as the sum of these n terms equals 1. I'm changing everything to the variables that represent them, or the symbols. 1 was the first term. We call that A1. Plus A1 times, what's 5 in this problem? The growth ratio, or the common ratio. It's called R. Then you have A1 times R squared. Plus, this one would be A1 times R cubed. And this pattern would continue until you get to the last part, which is always A1 times R to the n minus 1. We always stop with times R to the n minus 1. So this is where we begin our derivation of this formula. Okay? I'm trying to get from here to here. And how the heck are we going to get there? Somehow, in all of this empty space, we're going to take what's up there in green and turn it into what's down here in green, and that means it's a good formula that you can use. Okay? Here's how the proof begins. Here's how the derivation begins. Multiply both sides of this equation, multiply both sides by R. Multiply both sides by R. The left side would say sum times R. The right side would say, if I'm multiplying this entire thing times R, I would multiply each term times R. So this one would become A1 times R plus this one would become A1 times RR. What's RR? R squared. Plus This term would become a1 times r, which is r cubed. This one would be a1 times r to the fourth. I'm going to put some dots. That means that it continues, right? Each exponent is getting bumped up by 1. So where will it end? It will end when this guy gets its exponent bumped up 1. So what will that last term look like? What's n minus 1 plus 1? N. Next step in proofs, in some algebraic proofs, is to subtract one equation from the other. Let me ask you this. Does this equal all of this? What's this symbol say? Equals. So can I subtract this from the left side and all of this from the right side if they're equal? Is that legal? Yes? Okay. So on the left side, tell me what this would look like if you subtract s sub n minus s sub n times r. That's what this rectangle would look like if I wrote it with a subtraction sign, okay? Now here's where the magic happens. On the right, I have a1 plus a1r plus blah, 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 plus blah, 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 minus all of this. So do you see what's going to happen? What would that look like if I have a1 plus a1r minus a1r? What happens with a1r? It cancels. Plus a1r squared minus a1r squared. Cancels. a1r cubed minus a1r cubed. a1r to the fourth minus a1r to the fourth. a1r to the fifth. This continues to happen. These continue to eliminate. They continue to cancel until who in this line is sitting right in front of this guy? Plus a1r to the n minus 1. And I'm about to do what? Canceling. So who is left standing in this entire sentence? Is a1 still here? Did a1 cancel with anyone? Is a1 crossed out? No. So a1 is still standing. Everybody else got canceled, except minus a1r to the n. Is this starting to look like the formula we want it to look like? We're really close, right? Is this the numerator of the formula we're trying to get to? Yes, it is. All we need now is its denominator. And here's a little trick. What do these two terms have in common? We did this with logs earlier this week. If they have this in common, remember they had an x in common, so you factored it out? If I factored out Sn out to the front, what would be left here? 1 minus r. Last step, how do you get Sn by itself? Divide both sides by 1 minus r. And that's why it ends up in the denominator under that numerator. That is the derivation, which means kind of like the proof of why that formula works. Okay?